Tonight's video is about solving quadratic equations using the completing the square method. Some quadratics are fairly simple to solve because they are of the form of something with x squared equals some number, like this one. This quadratic is fairly simple to solve because it has this squared equal to something. And so to solve that, we would just take the square root of each side, like that. Then adding 4 to each side, we get x equals 4 plus or minus the square root of 5. And so you can write it this way: x equals 4 plus the square root of 5, or x equals 4 minus the square root of 5. Now, unfortunately, most quadratics don't come already set up to solve this way. And so for your average everyday quadratic, you first have to use the technique of completing the square to rearrange it into a neat squared part equals a number part. And so you can use the completing the square method to solve any quadratic equation. Now, these first couple of problems, we're just going to find the term that will make these expressions a perfect square trinomial. So it's going to look like x plus some number or minus some number squared. That's what we're trying to make these two problems look like. Now, in order to do that, I'm going to go ahead and erase that now. You have to take the coefficient of the b term, divide by 2, and square it. So remembering that in a quadratic equation there's a, b, and c. So doing that for this first example, we would take the negative 12, divide by 2, and square it. Okay, so this negative 12 over 2 is really negative 6 to the power of 2, which is 36. So then our trinomial would look like x squared minus 12x plus 36. If I wanted to write it in the factored form, it would be x minus 6 squared. Likewise, down here with this trinomial, I take the b term, divide by 2, and square. And so this trinomial would end up as x squared plus 3x plus 9 over 4. And the 9 over 4 comes from 3 squared and 2 squared. To write it in its factored form would be x plus 3 over 2 squared. Now we're actually going to solve this quadratic equation with the completing the square process. Your first step is to always make it look like this: x squared plus bx equals whatever your constant is. Okay, so our first step in this one is to remove this 57 to the other side. And since it's positive on this side, it's going to become negative on the other. Now, I left this space here because that's where my term is going to be that I complete the square with. Okay, now remember, to find that term, we're going to take our b term, 16, divide by 2, and square. And so this is really 8 squared. And so we're going to add that term in, and because I do it on the left side, I also am going to do it on the right side, because you have to keep your equation balanced. Okay, so this trinomial is going to become x plus 8 all squared. The reason it becomes x plus 8 all squared is because 8 times 8 is 64. And so then if I were to factor that trinomial, these are the two factors I would get. And so now all we'd have to do is solve this remaining equation. So I'm going to add next the 57 plus the 64. That gives me x plus 8 squared equals 121. So I'm going to take the square root of each side. So I'm left with x plus 8 is equal to plus or minus 11, because the square root of 121 is 11. So now I'm going to have x plus, not x plus, I've got to subtract 8 from each side. So x is going to be equal to negative 8 plus or minus 11. So if I do negative 8 plus 11, I get 3. If I do negative 8 minus 11, I get x equals negative 19. And so there's our final two answers. Now, getting integers for answers, that tells me that this trinomial could have been factored using the traditional factor methods, like we do with the x, and we try to figure out the two numbers that multiply to 57 but add to 16. However, you can also see that it can be done by completing the square. So if you get stuck on one of these, where you can't figure out the factors, you can always complete the square. Okay, this final example is slightly different because we're going to have to take care of this term with our x squared, the leading coefficient. We can't have that there to do the perfect square trinomial. So, but our first step is still going to be to remove the constant to the other side. And so we're going to add 5 to each side to do so. So I've added the 5 to the other side. And now to take care of the 4, I'm going to divide each term by 4. So I've divided each term by 4, and this is what I'm left with. And so now I just have to get whatever term I need to put here to complete my square. And to do that, remember we take half of the b and square it. So off to the side here, I've taken my b divided by 2 and squared. And that gives me negative 1/4 squared. Now I could take this a step further and make it positive 1 over 16 and add it to each side that way, but I'm going to leave it in this form because it's easier to see what you're supposed to use for the next step. And so bring it down here and adding that term to each side, I now have this trinomial, and then I have these couple terms over here on the right. This trinomial is now going to be able to be a perfect square trinomial, and that's going to factor into x minus 1/4 squared. So we've got x minus 1/4 squared equals 21 over 16. We just combine these two terms. And now to solve this equation, I need to take the square root of each side. Okay, so taking the square root of each side, I get x minus 1/4 equals the square root of 21 over 4. Because the square root of 21 I can't simplify any further, the square root of 16 is 4. And so now I can write my answer as x equals 1/4 plus or minus the square root of 21 over 4. And I'm going to leave it in this form because the square root of 21 does not further simplify unless you approximate it with a decimal. And I don't want to do that. I want exact answers, and so it's fine to leave your answer in this way. And that's all for our video today.